Okay, this video will go through parallel lines and perpendicular lines. So let's start the video by going to page 28 in your notes, and let's just talk for a few minutes about what parallel and perpendicular lines mean. If you have lines that are parallel, they never intersect. Algebraically, you know lines are parallel if they have the same slope. So visually, you can see what's happening here. The lines will never intersect, and that would mean they have the same slope. Perpendicular lines intersect to form a right angle. And algebraically, you know when two lines are perpendicular, if their slopes are opposite reciprocals. When the slopes are opposite reciprocals, that means that the lines are perpendicular to each other. Another way to think of it is the product of the slopes is always -1. So when you multiply the two slopes together, you always get a product of -1. So here are some problems to help you understand or visualize what that means. What are negative reciprocals, opposite reciprocals? If you start with 3/4, the opposite reciprocal, well, opposite meaning, she uses the word negative, or you can use the word opposite. So that means I would be looking at negative, and I would take the reciprocal. So positive 3/4 and -4/3. If they were slopes, they would be perpendicular lines. If I start with the +2, that means I'm looking at 1/2 as the reciprocal, and I take the opposite sign. So -1/2 and +2 are opposite reciprocals or negative reciprocals. If I start with -7/8, that means the opposite reciprocal is positive, and then I would take the reciprocal of that, 8/7. If I'm looking at +1, its opposite reciprocal would be -1. And 0, if you have a slope of 0, that implies that you have the horizontal line. And the opposite of the horizontal line would be the vertical line with no slope. So that's kind of a trick question. So that would be your horizontal vertical lines for number 5. And then you can quickly see that if you take the product, meaning if you multiply the two numbers together, the product is always -1, with the exception of number 5, but that is a trick question. So -7/8 times +8/7, the product of each of these will always be -1. So that's another little check trait. All right, now let's move to page 25 and work through a few problems together. So parallel equations, parallel lines, parallel equations have the same slope. Or equations of lines that are parallel would have been better wording for that. Equations of lines that are perpendicular to each other have slopes that are negative or opposite reciprocals. Okay, so let's run through a few of these together. Let's go through example 1 first. So you're given a line and you're asked to find the equation of a line that would be parallel to the line that's given, but I would like for my new equation to go through the point -2, +7. The only information I need from my given line is its slope, and then I put it aside. That's all I need. So I'm going to use this model, and I would let y become 7, m is -4, x is -2, and that allows me to solve for a different b. So I have 7 equaling 8 plus b, -1 is b. So the final answer, y equals -4x minus 1. So my new equation has the same slope as the given equation, but I have different y-intercepts. I go through the y-axis at 2 different points, and that forces you to have 2 different lines. So let's do example 2 together. And in example 2, the equation is given in standard form. There is a way to do that, but I think for us the easiest thing to do would be to take this and convert this to slope-intercept form. So I'm starting here and I would subtract the x from both sides and then divide by 3. -3 rather. So this allows me to quickly identify my slope. So my slope is 1/3. This is my old line or my given line. And I'm now going to write the new line that's going to be parallel to the old line. So the only information I need from my old line is its slope, and I'm given a specific point. So y is -1, my slope is 1/3, x is +3, allowing me to solve for b. So -1 equaling 1 plus b, b is -2. So the parallel equation would be y equaling 1/3 x minus 2. So the two lines would be parallel to each other. They have the same slope but different y-intercepts. Let's do the perpendicular examples. So example number 1, or excuse me, example number 3 is given in slope-intercept form. So the only thing I need from the given line is its slope. But I'm looking for a line that would be perpendicular to the given line. So I have a point, an x, and a y. I need to determine what my perpendicular slope is. If my given slope is +2, my perpendicular slope would be -1/2. And then you run through the routine again. Y is 3, my slope is -1/2, x is 4, so b is 5. So my perpendicular equation would be y equals -1/2 x plus 5. So if I were to graph the pair of lines on the same grid, they would intersect to form a right angle. And you can see that if I multiply +2 times -1/2, that product is -1. Let's do example 4 together, and then you all can take it from here and do your homework. So example number 4 is given in standard form. So let's take this and convert this to slope-intercept form. So it's easy to see that my slope is -5/3. I need the perpendicular slope. So the perpendicular slope would be +3/5. And I'm given a point with an x and a y. X is -5 and y is +1. So you run through the routine again. +1 and set that equal to 3/5 times -5 for y equals mx plus b, allowing you to solve for a new b. So the 5's will take each other out. The negative remains. So I now have 1 equaling -3 plus b, adding 3 to both sides, b is 4. So here's my final answer. Y equaling +3/5x plus 4. So here's my perpendicular equation. And here is the equation that I've taken to start, took that equation, manipulated it. So the two lines would be perpendicular to each other. You can see that their slopes are opposite reciprocals or negative reciprocals.